Okay, good morning. Welcome to
Fun Math number 36.
FunMath number 36. We're taking a little bit of extra time this weekend to do a video because we're going to be gone at the end of the week. So we're going to take some time off at the end of the week, so we'll do a little more work at the beginning of the week. Today we're going to look at two really cool problems that don't seem like they're similar at all, but they turn out to have solutions that are really similar. Okay? And so I just thought it'd be neat to kind of review this so you can see some really cool stuff from number theory. Okay, so problem number one. Find 1 plus 2 plus 3 plus 4 all the way up to plus 12. So that's adding up the integers 1 through 12. Okay, go ahead.
So 1 plus 2 plus 3 plus all the way up to plus 11 plus 12. A cool way to do this is write it backwards. 12 plus 11 plus 10 plus 2 plus 1.
Okay, so instead of just jumping in and adding it all up, you wrote it backwards. Now why did you do that?
Because it makes it a lot easier.
It doesn't look easier to me. Looks like we've just had the same problem twice now.
So when you add this all up, you get 13 plus 13 plus 13 plus 13 plus 13.
Oh, that's interesting. So now I just have to add up a bunch of 13s. So how many 13s do I have there?
You have 12 13s.
Ah, so what does that add up to?
12 times 13.
Okay, so go ahead and write that down. Ooh, but I don't know what 12 times 13 is, so is that... Well, you explain it.
No. So 12 times 13 is twice the answer.
Why is it twice the answer?
Because you added up, these two things are the same thing, only one of them's backwards.
Ah, okay, great.
So you have to divide this by 2.
Okay, so 12 times 13 divided by 2. Ooh, that looks pretty complicated.
Well, it's the same thing as 6 times 13.
Ah, 6 times 13. Well, maybe that's not too
Yeah,
complicated.
that's 78.
Okay. Alright, so that's pretty neat. So when we're adding up a bunch of numbers, one sometimes really cool way to do it is write the numbers backwards, add those together first, and then it makes our sum much easier. Now we just have to add up 12 13s, which is 12 times 13. And that's twice what our number is because we added what we were supposed to add up twice.
Yeah.
So we divide by 2, 6 times 13, and that's just
78.
78. Cool. That's really cool. So you could even do that for adding up the numbers from 1 to 100 or 1 to 1,000 or 1 to 253. Pretty neat, right?
Yeah.
Okay. Cool. It's adding without adding. Okay? Now, find the product of the divisors of 12.
Well, the divisors of 12 are 1 and 12, 2 and 6, 3 and 4.
Okay, so now we have to multiply all those numbers together.
Sneaky way to do it is we can make a list.
Scoot over a little bit.
Oh, 1, 2, 3, 4, 6, and 12.
Okay. 1, 2, 3, 4, 6, and 12. Okay, what are you going to do now?
Then I'll do the same thing, write it backwards. 12, 6, 4, 3, 2, 1.
Okay.
Then we multiply these two together.
Okay. Well, what do you get when you multiply those two columns together?
You get 12 times, 12, you get all 12s.
Okay, and what do you get? How many 12s do we have?
We have 12, we have 6 12s.
6 12s. What do you get when you multiply 6 12s together?
You get 12 to the 6th.
Oh, that's interesting. So is that our answer? The product of those is 12 to the 6th?
No, we have, this is twice that.
It's...
This is twice what we're looking for.
Are you sure about that? That it's twice what we're looking for?
Well, this is what we're looking for the product of this.
Yeah.
So we wrote it backwards and multiplied it together.
Okay, and so what is this? This is not twice what we're looking for.
No. It's what we're looking for squared.
Why is it what we're looking for squared? Scoot that way a
Because we
little.
multiplied the two same things together.
This time we multiplied all the numbers twice. So this is 1 times 1, we have 1 squared, we have 2 squared, we have 3 squared, all the way up to 12 squared. So we multiplied all the numbers twice. So the first time around we added all the numbers twice and got a number that was twice what we were looking for. This time we multiplied all the numbers twice. So 12 to the 6th is the square of what we're looking for. Do you see that?
Yep.
Because we multiplied all the numbers twice. So what's the answer that we're actually looking for if we multiplied all the numbers
We
twice?
need to find the square root of 12 to the 6th.
Whoa, the square root of 12 to the 6th.
I'm not sure if that's on camera.
I hope it is, but how do we find the square root of 12 to the 6th?
Well, it's whatever squared is 12 to the 6th.
Right,
That's 12 cubed.
12 cubed. Okay. Go ahead, write it down.
The square root of 12 to the 6th is 12 cubed.
So that's really interesting. So when we multiply all the divisors of 12 together, we get 12 cubed.
Whoa.
Whoa. How cool is that? 12 cubed. So adding the numbers up to 12 and multiplying the product of the divisors of 12 are very similar problems, and we solve them using a very similar strategy. One time we have to notice that in our strategy we've added the numbers twice to make it easier. Then the second time around we multiplied the numbers twice to make it easier, and at the end we just have to make an adjustment for that. So the product of the divisors of 12 is 12 cubed. And we can do the same thing for any number, right?
Yep.
Pretty cool. Good job. Good job. Those are tricky things to explain.